Welcome to our machine learning mini project, where you'll embark on a journey to create and document your very first complete ML workflow. How do we build, train, and document it all? Let's dive in. Start by captivating your audience with a captivating question or a surprising fact. Mix concise statements with a few detailed explanations to keep things engaging. Progress seamlessly without using overused transitions. Skip filler phrases and meta-speech. Opt for active voice and vibrant verbs. Remember, clarity is key. Cluster ideas into mini beats if needed. And as we explore, aim for a 30 to 45-second narration, leaving us with a clear, impactful takeaway. Let's unleash the power of machine learning together. Welcome to our course overview. Today, you'll dive into the essentials of building a strong foundation in machine learning. Start by crafting a baseline model to set performance standards. Then, master the training process, monitoring metrics, and troubleshooting along the way. Learn to evaluate effectively, selecting the right metrics and confidently interpreting outcomes. Dive into creating clean pipelines for code that's readable, reusable, and maintainable. Lastly, discover the art of documenting findings clearly for reproducible results. Stay tuned as we unravel the keys to success in machine learning. In the world of machine learning, understanding the structured workflow of a project is key to success. From data collection to deployment, each phase in the pipeline builds upon the last, creating a solid foundation for your final model. Begin by gathering, cleaning, and exploring your dataset. Then, establish performance benchmarks with a baseline model. Iterate and optimize through model training, and validate results in the evaluation phase. Remember, a successful ML project is a journey, not just a destination. Why start simple when building your baseline model? Your baseline is the foundation for measuring improvement, serving as a straightforward approach to your problem, like linear regression for continuous targets or logistic regression for classification tasks. By beginning with a baseline, you can gauge whether more complex models truly add value. If a sophisticated neural network only marginally boosts accuracy compared to logistic regression, perhaps simplicity is the smarter choice for production. Quick to implement and debug, a baseline sets a performance floor, uncovers data quality issues early, and offers a reality check for intricate models. Remember, your baseline doesn't have to be fancy. Even a basic rule-based system or average prediction can be a valuable reference point for progress. When diving into machine learning tasks, choosing the right baseline is crucial. For classification problems, kick off with logistic regression or a simple decision tree. If dealing with multi-class problems, experiment with a naive Bayes classifier for quick training and interpretable outcomes. In regression tasks, consider starting with linear regression or calculating the mean of your target variable to assess predictive potential in your features. For image analysis, leverage pre-trained models like ResNet or a sleek CNN with few layers, utilizing transfer learning for robust image classification baselines. In text analysis, explore bag of words with logistic regression or a basic recurrent network, as TF-IDF features often excel in text classification. Experimenting with these foundational models can set the stage for more advanced techniques. In the training process, precision is key. Split your data into training, validation, and test sets, preserving the sanctity of the final evaluation. Next, initialize your model with care, setting up architecture and hyperparameters. Then, dive into the training loop, feeding data batches, calculating losses, and updating weights. Keep a vigilant eye on overfitting, underfitting, and convergence, visualizing progress with learning curves. Remember to save checkpoints regularly, especially after validation improvements, ensuring resilience against crashes. Stay focused, stay vigilant. Ever wondered how to gauge your model's learning progress during training? Enter training metrics. Your key allies in this realm are the training loss and validation loss. The training loss tracks how snugly your model fits the training data, ideally decreasing steadily. If it plateaus, check learning rate or data prep. Meanwhile, the validation loss evaluates performance on unseen data. When it spikes as training loss dips, overfitting looms. the gap between these losses? A treasure trove of insight into your model's generalization prowess. A slim gap signals robust generalization, a wide one, overfitting. So, heed these metrics well to steer your model's training journey effectively. Remember, metrics speak volumes in the language of machine learning. Are you facing hurdles in your training process? Let's troubleshoot common issues together. When your loss doesn't budge, try adjusting the learning rate, scrutinizing data pre-processing, and confirming label accuracy. If your loss skyrockets, swiftly lower the learning rate, introduce gradient clipping, and normalize inputs to tackle nan or infinity values. Dealing with overfitting? Implement dropout, embrace data augmentation, or perhaps simplify your model to balance high training accuracy and low validation scores. And if your training drags on, consider tweaking the learning rate, experimenting with optimizers, or adjusting batch sizes for more efficient convergence. Remember, adapting these solutions can pave the way to smoother training experiences. Ever wondered how to truly gauge if your model is a success? Evaluation is key. Selecting the right metrics is vital, as each metric paints a unique picture of your model's performance. Accuracy isn't always the answer. Consider precision, recall, and F1 score for imbalanced classification, and MAE and RMSE for regression analysis. Remember, the test set is sacred ground, reserve it for final validation to avoid inflated results. Dive deeper than a single number. Confusion matrices, ROC curves, and error analysis offer invaluable insights into your model's strengths and weaknesses. In this world of model evaluation, the right metrics make all the difference. Ever wondered how to measure the success of your classification or regression tasks? Let's dive into the key evaluation metrics by task. For binary classification, we have accuracy for overall correctness, precision for the accuracy of predicted positives, recall for the actual positives found, F1 score as a blend of precision and recall, and AUC-ROC to gauge discrimination. In multi-class classification, assess accuracy, macro F1 for class equality, weighted F1 for class frequency, and the confusion matrix for visual performance. For regression tasks, track MAE for interpretability, RMSE for error penalty, R superscript 2 score for variance explanation, and MAPE for percentage errors. Each metric provides a unique insight into your model's performance. Remember, understanding these metrics is crucial for refining your models effectively. Ever wondered when 85% accuracy is truly good? Well, it depends. Consider predicting rare diseases. A model always guessing healthy achieves 99% accuracy but is utterly worthless. Context matters most. Compare your model to baseline results, human experts, and industry benchmarks. Reflect on business needs and error costs. Keep in mind, a simpler model at 82% accuracy, explainable and maintainable, might trump a complex black box at 85%. Remember, numbers alone don't paint the full picture. Interpret your metrics within your specific application to truly grasp their significance. Takeaway: context is key in understanding and assessing model performance. In Chapter 4, we delve into the art of creating a clean ML pipeline. Picture it as transforming a messy bedroom into an organized workspace. Both may work, but one streamlines life. Modular code is key. Break it down into functions with distinct roles and clear names. Configuration files are crucial for storing parameters and paths separately, ensuring easy experimentation and code cleanliness. Git is your best friend. Commit frequently with clear messages from day one to document your progress. Don't forget logging and monitoring. Track execution details and errors to enhance your workflow. Remember, a well-structured pipeline is the backbone of your project's success. In the chaotic realm of project structures, clarity reigns supreme. Picture this: a jumbled mess of files with cryptic names, a labyrinth of confusion. Impossible to navigate, impossible to scale. Now, envision a better way. Neatly organized folders, each with a purpose. Data, source code, configurations, all in their place. Easy navigation, clear intentions. No more wasted time hunting for files. efficiency, scalability, and sanity restored. Remember, in the world of project structures, organization is power. In the world of essential pipeline components, data loading sets the foundation by ensuring data integrity and type validation. Pre-processing steps further enhance data quality through normalization and encoding, with parameters saved for seamless future transformations. Model definition emphasizes flexibility, separating architecture from training for easy model swapping. Training and evaluation scripts streamline processes, offering control via command line arguments and automatic metric tracking. Each component plays a crucial role in optimizing machine learning workflows. In Chapter 5, Writing Your Project Report, your report serves as a vital communication tool, detailing what you constructed, why it was built, and the insights gained. A well-crafted report not only makes your work reproducible but also aids others in comprehending your rationale. Begin with an engaging introduction and problem statement, setting the stage by defining the issue, dataset, and predictive goals. Dive into data exploration and pre-processing, showcasing key data insights, cleaning processes, and data transformations. Transition smoothly to methodology, elucidating your model selection, training approach, and validation techniques with sound justifications. Progress to results and analysis, illustrating performance metrics and model comparisons, dissecting successes and shortcomings. Conclude with a thoughtful summary in conclusion and future work, encapsulating key discoveries and proposing actionable steps for model enhancement while acknowledging potential areas for refinement. Ultimately, your project report encapsulates the journey from problem statement to actionable insights, paving the way for future advancements. Time, approximately 40 seconds. Takeaway: crafting a meticulous project report not only encapsulates your journey but also lays the foundation for future advancements. Are you ready to level up your documentation game? Let's dive into the best practices for creating clear and effective documentation. Start by crafting a README that serves as a roadmap for your project. Detail its purpose, installation steps, and execution guidelines with working command examples. When commenting your code, go beyond just the what and delve into the why to enhance understanding. Opt for descriptive docstrings to clarify functions' inputs, outputs, and objectives. Keep a detailed log of your experiments to avoid redundant efforts and pinpoint successful strategies. Don't forget to list your project's requirements and dependencies in a concise requirements.txt file for easy replication. By following these practices, you ensure both clarity and reproducibility in your work. How do you ensure your machine learning work stands the test of time? By prioritizing reproducibility. Imagine being able to revisit your code months later or sharing it with a colleague who can effortlessly replicate your results. The key steps? Set fixed random seeds, document versions, save model checkpoints, note hardware specifics, and track data versions. Test your reproducibility by having a friend run your code independently. Can they follow your instructions, train the model successfully, and achieve results close to yours? If not, refine your documentation until they can. Reproducibility isn't just good practice, it's essential for robust science and professional ML work. Have you checked off every box on your ML project checklist? Ensure your data is prepped, models are developed, and results are evaluated with precision. Organize your code, document thoroughly, and prioritize reproducibility. Stay on track to deliver a comprehensive and professional machine learning project. In the ever-evolving world of modeling, remember this: start simple, then iterate. Building a baseline model first sets the stage for understanding the value complexity adds. Keep in mind, simplicity often wins in solving real-world problems. Don't overlook the importance of organization matters. Clean code and thorough documentation are not mere options but vital skills. Your future self will appreciate the clarity when revisiting a project. When it comes to evaluation, choose metrics that truly reflect your objectives. Dive deeper than single numbers to grasp the essence of your model's learning process. And always reserve the test set for that final crucial evaluation. Lastly, reproducibility is professional. Secure your credibility by setting random seeds, documenting dependencies, and ensuring your code runs smoothly on a fresh setup. Remember, reproducible research is credible research. In summary, remember these key principles: simplicity first, meticulous organization, insightful evaluation, and unwavering commitment to reproducibility. Let's test your understanding with a quick quiz. 1. Why build a baseline model first? It provides reference points, aids in debugging, and helps measure improvement. 2. When to use validation versus test sets. Validation for hyperparameter tuning and model selection, test set for final evaluation. 3. Why might 95% accuracy be misleading? Consider class imbalance, cost of errors, and the need for alternative metrics. 4. Document key aspects for reproducibility, random seeds, dependencies, data versions, and hardware used. 5. A project README should include setup instructions, usage examples, and a project description. Apply these concepts to your own ML project starting with a baseline model. Remember, good ML projects are built step by step. Good luck!